Continuing on through the solar system, I want to talk about the planet Saturn. Probably the most recognizable object in all of astronomy because of its rings. The rings of Saturn were almost discovered by Galileo. When Galileo drew Saturn, he drew it with two little bumps on the side, but he couldn't, his telescope wasn't quite good enough to see that the rings go all the way around. The rings of Saturn, the discovery of the rings of Saturn, I believe, are accredited to the Dutch astronomer Christian Huygens in the later part of the 1600s. Saturn is about 9 to 10 times further away from the sun than the Earth, about 9.5 astronomical units. So it gets almost 1/100th the amount of sunlight as the Earth does, and quite a bit less than Jupiter. So where Jupiter's clouds are very dynamic with lots of activity, Saturn's clouds are much, much more sedate. There's some structure in there. You can still see that it has these kind of stripes indicative of these low pressure and high pressure systems, but not nearly as spectacular as Jupiter's. Like Jupiter, though, the atmosphere of Saturn is largely hydrogen, about 96% hydrogen gas, a little bit of helium, and like Jupiter, trace amounts of things like methane and ammonia and ethane and ices in the atmosphere, like ammonia ice, water ice even in the atmosphere. Because we are so much further from the sun, though, the temperature at the cloud tops of Saturn is quite a bit less than Jupiter. Remember, Jupiter was about 250 degrees below Fahrenheit at the tops of the clouds. Saturn is more like 300 degrees below 0 Fahrenheit. So as we go out from Jupiter, Saturn, Uranus, Neptune, we get about 50 degrees colder each time as we head out to the edge of the solar system, where the temperature of things is pretty darn close to absolute zero, a handful of degrees above absolute zero. So because less sunlight, less heat, less dynamic atmosphere, a little less active than Jupiter's. Again, we can see these belts and zones, these high pressure and low pressure systems when we look at the surface of Saturn, but the thing that draws our attention that we'll talk about the most today is the rings. This picture was taken, I think, by the Voyager 2 spacecraft. The Voyager 2 flew past Saturn in the early 1980s, and since then the most important mission to Saturn is the Cassini mission, which we'll talk more about when we talk about Saturn's moon Titan. The Cassini has taken pictures of the polar regions of Saturn for the first time, just like Juno took pictures of the polar regions of Jupiter for the first time. One of the most interesting features of Saturn's polar regions is the clouds make this sort of hexagonal shape that scientists are still kind of figuring out how to model properly, how to make sense of why there would be this perfect hexagon. It seems weird for clouds to make a hexagon, and yet that's the shape we see. And we also see these little oval storms, these little hurricane-like storms, the same sorts of things we saw on Jupiter. We see them on Saturn as well. Here's a close-up from the Cassini spacecraft of the polar region, showing some high clouds kind of swirling around. So there is some action in Saturn's atmosphere, just not quite as exciting as what goes on in Jupiter's atmosphere. This is a photograph of Saturn's North Pole showing that Saturn has an aurora. It has a bit of a magnetic field, and magnetic fields guide electrically charged particles from the solar wind, and when they hit the atmosphere, they cause it to glow. This is actually, the glowing is in the ultraviolet. This is a composite image. It's a visible light photograph composited with an ultraviolet image showing that aurora. When we look at the rings, we see some interesting things, and we have known for quite some time, first of all, that the rings are not a solid object orbiting Saturn. They are a collection of individual tiny particles that are all in orbit around the planet, ranging in size from snowflakes and grains of sand on the small end to gravel and rock-sized bits of material, refrigerator ice cubed chunks of ice, up to things the size of cars, houses, maybe even a large building. And there's no clear dividing line when we talk about the stuff that Saturn is made out of, the Saturn's rings are made out of, between a big ring particle and a small moon. You could call some of the largest objects that orbit in Saturn's rings, you could call those moons. You could call every one of them moons. Saturn has billions of moons, some of them as small as a grain of sand. But they all orbit around Saturn under the influence of Saturn's gravity. And they have a structure to their orbits that's really, really complicated. One of them has been known about since, I think, the 1700s, named after Cassini. The Cassini division is an actual gap in the rings. There's a hole there where there's nothing orbiting, or much less stuff orbiting in that gap than there is everywhere else. And if you look closer at the rings of Saturn, you can see that they have this very fine structure of lots of little places where there's spaces in the rings and lots of places where the rings are bright, so there's lots of material orbiting there. The reason for that is the fact that Saturn has lots of moons. Depending on what you want to count as a moon, it has more than 80 moons. 10 of them big moons. If we just pick one of its moons at random, I picked Mimas. Mimas orbits around Saturn about every Earth day, 0.942 days. So every little less than 1 day on Earth, Mimas goes in orbit around Saturn. The closer you are to a planet, the faster you orbit it. If we imagine objects orbiting anywhere in space between Mimas and Saturn, there is a point in space where an orbit here would take exactly half of Mimas's orbit. Mimas orbits every 0.94 days. An object here would orbit twice every 0.942 days, or whatever half of 0.942 is, 0.471 days. A little early in the day for me to do math in my head. Whatever that number is, if you imagine a particle orbiting at this point in Saturn's rings, every time it gets back to this point, Mimas is always there. And when Mimas is here, every time it gets to that point, Mimas is always there. And so Mimas is always exerting a little bit more of a gravitational tug on objects that are located right at this point in the rings. What that gravitational tug does is it clears out a gap in the rings at a location that corresponds to exactly half of Mimas's orbital period. And if there are 80 moons, and they all do that, that makes 80 little gaps in the rings. And not only will it clear out a gap at the 1/2 point, it'll clear out one at the 1/3 point, and the 1/4 point, and the 2/5 point, and the 3/7 point. Any fairly even ratio of the orbit of a ring particle and the orbit of the moon, that ring particle is always going to be getting a little yank from that moon and a little yank out of that resonant orbit. And these orbital resonances are what create these little gaps in the ring system. They're all caused by the interactions between the gravitational pulls of the moon and the point in space where an object would be orbiting if it wasn't always getting yanked out of that spot by some moon of Saturn. If we look at this rings up close, we can see hundreds of these little gaps, all corresponding to some kind of orbital resonance between the potential orbit of an object here in the ring and some moon out there that's always giving it a little yank out of that space, creating a little gap in the ring. There are also either small moons or large ring objects, ring chunks, that orbit in the rings and can either clear out a gap in the ring or disturb the orbits of objects in the rings. When we look at this picture of the ring, we can see this kind of twisty, something's going on here in the ring, and what's happening is the gravitational pull of a large moonlet in the ring is messing with the orbits of the little tiny snowflake-sized, ice cube-sized, gravel-sized, sand-sized bits of the ring and causing them to move in this more complicated way. Here's one where you can, I don't know if you can see it on this video, there's a tiny, tiny dot right there. It's a little moon called Prometheus. And you can see here in the rings the little ripples being caused in the rings by the gravitational pull of Prometheus. So the upshot of this is that the Saturn ring system is almost like its own little solar system. There's 80-some moons, there's billions of little bits of dirt and ice orbiting the planet, and they're all gravitationally pulling one another, leading to a very, very complicated and interesting system. What else do we want to say about Saturn? I'm not going to talk about Saturn's moons, because it's got too many. And I stopped counting years ago. I looked this up on Wikipedia today just to see how many moons Saturn has nowadays. When I was a kid, and you open an astronomy textbook, I think it was 10. It was either 10 or 12 back in the early 1980s, before Voyager 2 flew by and discovered a bunch more, and then all these spacecraft flew by and discovered all these moons of Saturn. So I'm going to give the moons of Saturn their own little video. I'm not going to talk about all 83 for sure. Some of them are just tiny little rocks that I don't really care about. But there are two that we do want to talk about. One is Titan, which, despite the scale here, is the biggest moon of Saturn. And just by looking at it, you can tell it looks very, very different from all these other moons. Titan is the only moon in the solar system with an atmosphere, and it is important enough to get its own video. And so we'll talk about Titan separate from Saturn in a later video.